this is your last video lesson. There's no test for this. Just get in your homework. I think I mentioned it a few times. Congratulations, you're here, right? And we're talking about your last assignment, which is Trig Identities number 2. It's funny. We didn't get through all the course, right? I had to slow things down because some people just aren't even participating, some people behind. And I have to be COVID conscious, right, and not go too fast. So there's probably about 5 or 6 lessons left on the table that we didn't get to, which is kind of bums me out a little bit because I'd like to get there. There's some fascinating things. I mean, you'll probably see some of it at university, but I had to make a decision, especially in the last couple of weeks, about which ones I was able to cut and which ones I was going to keep. And so today, and this is your last one, we're going to look at the notion of a trig proof, or a mathematical proof. And to start that off, I'm just going to re-go over our trig identities from the last assignment. Well, the ones that come from tangent and cosine, so all those triangle ones, right? It's good to have those. And then I'll write out our Pythagorean ones, the ones that come from, sine squared and cos squared and all that kind of stuff. So I'll have them out, and then I'll remind you to write this time down so that you can scroll back to it in the video if you need to, or maybe you should write them out yourselves actually, so you have them at your ready. Because having these trig identities easily accessible makes a huge deal. And if you've done the homework from last day, especially when we get to the algebra section where you're converting and trying to sort things out, having these trig identities easily accessible speeds up the time that it takes you to do this work, like very, very quickly, or it's much better than if you're trying to figure them out from scratch all the way through. So having a little cheat sheet for yourself goes a long way. So let me write out the algebra triangles and the Pythagorean ones and a couple other small ones that a lot of people forget about that they shouldn't. Okay, and and you guys might want to try to do the same. Okay, so to start off, right, you got your tangent is sine over cos, so it's inverse. Cotangent is cos over sine, and that's what these two algebra triangles talk about. This goes back to the last lesson. And from these guys, we can make all these other 6 ones. So I'll hold this up. You guys might want to copy it down for yourself. Okay, and if you noticed, down here I also wrote our reciprocal one. So sine times cosecant is equal to 1. And this is like an algebra triangle in itself, right? I mean, I can divide both sides by cosecant, or I can divide both sides by sine. So let me just kind of reiterate this a little bit. Okay, so sine times cosecant is 1, so sine is 1 over cosecant, and cosecant is 1 over sine. Now this goes back to many weeks ago when we talked about our reciprocal trig ratios. And so I don't really write them out, but it's good to have, because if I want to disguise a value of 1, I might write it as sine times cosecant. Right? Just like how I disguised some of those algebra problems in the last lesson. So I'll write out the 3 of them, and you can do your algebra how you see fit. But it's good to remember how sine and cosine and those guys are related to their reciprocals. So let me write that out. Alright, so that's those 3, and of course you can do algebra. You could set up an algebra triangle for those if you like, and you could have 3 more algebra triangles. But these are pretty basic ones, and so I don't bother writing them out in algebra triangles. You should know that secant is 1 over cosine, or tangent is 1 over cotangent from previous work. But it's there because you will need to remember these details. Okay, and then we have our Pythagorean ones, which I'll list up above. And then you might want to pause the video and make sure you have all these guys down on a sheet of paper while you do your work. Okay, so these guys up top, these are our Pythagorean identities. Those are the ones that have the squares. We proved all of this last lesson. And so that's an important detail. These have been proven to be true. And because all of these have been proven to be true, we can perform algebra on these to suit our needs. So for example, let's say I find I've got a 1 minus cos squared in my question, and that's disguised as something else. Well, because these have been proven to be true, I can do algebra to move this to the other side of the equation. So cancel it out here and minus it over there. So I have sine squared is equal to, well, the cosine is moved, so 1 minus cosine squared. So 1 minus cosine squared is sine squared theta. right? And in the proofs that you do today, this is what you're doing. You're removing the disguises that I placed on in the questions to break them down into simple expressions. So we'll go through some examples for that, but I want you guys to turn to the very first page of the booklet because I want to help you make a little cheat sheet for yourself. So here's the booklet, and if you open it up to the front page, I've got this, right? No, it's not the best clear. But what we have is we have our 6 algebra triangles up at the top, and you can fill those in. You scroll back a little bit on your bar. And then I've got 6 spaces to fill in different things that will equal, well in the first case, the different things that will equal sine or sine squared. So I'll help you fill in that first one, and you'll do the rest for yourself. And this will be kind of like your little cheat sheet so that you can remind you what some of the disguises for sine squared, and those things are. So let's have a look at how I would fill out the first square underneath those triangles. You can fill out the triangles yourself. It comes from this guy right here. If you need to, you can scroll back. Okay, so let's do that first box. Okay, so I ask you in the first box to come up with at least 5 different ways that you can get sine or sine squared from the algebra triangles that you have and from your Pythagorean ones. And we already talked about the first one. It's a change of your Pythagorean one. So let me just write that down. Right, I just did a little bit of algebra. I moved the cosine to the other side, and like I just showed you that just a couple minutes ago. So all of them have at least one of these Pythagorean ones which you can manipulate and move from one side to the other. But you use your algebra triangles to find the rest. So let's have a look. Okay, so I've just picked the algebra triangles that had signs in them, right? There's a sign there, there's a sign there, and the other one doesn't have a sign in it. Hold on. There we go. Okay, so there's a sign here, there's a sign there, and there's a sign there. So we can get 3 equations for our sine. Alright, so that's them there, but I asked to get 5. And there's one more. And I kind of mentioned it a little bit earlier in the video. Remember what it is? See if you can remember. Okay, it's the reciprocal, right? Sine theta is 1 over cosecant. So for each of those boxes, right, for each of these 6 boxes in here, you're going to have 5 different ways to get one of those expressions. And that's very, very handy because when you're going through these proofs, you need to be able to see the disguises that are made. So I'm going to make a proof up, right, and we'll talk a little bit about how to do it. Okay, so here's an example of a proof. And it looks pretty daunting, like there's a bunch of stuff in here. Now we've got to remember a few things. We don't know that this proof is true or not. Okay, it's true, I made it up, but we're going to assume that we don't know it. And because we don't know whether it's true or not, we're not allowed to do algebra across the equal sign. So our job then is to try to simplify as much as we can on both sides so that we have an expression on one side equal to the expression on another side. And so our job is to try to determine which disguises we need to cancel out. So get out your sheet and see if you can find any disguises in there that you know you can cancel out. I'll give you some hints. I'll pause the video and see what things you can decipher. Okay, there are 3 that are pretty easy to see, right? 1 minus sine squared theta, right? So that comes from, that's equal to cosine squared. If you look on your sheet, you'll see it. You can change that one. Cosecant squared theta minus 1, that's equal to cotangent. So on the right side, I could write this as cos squared theta over cotangent squared theta. That's what the top and bottom change to. And then over here on this side, secant squared theta minus tan squared theta, that's equal to 1. So this is really equal to 1 minus cos squared theta. Well, so I've deciphered 3 of the disguises, and now this gets to be a lot easier. What's 1 minus cos squared? Well, look on your sheet, that's equal to sine squared theta. So sine squared theta. And then cos over cotangent, that's also equal to sine. But these are squared, so this is equal to sine squared theta as well. And now we have two expressions that are equal. And so I've proven that these are the same. And when we're proving them, we can say that both sides are equal. And you know how I like to put my little money symbol there, because it's money. Money in the bank. Okay, so that's how you do proofs, is you start looking for the disguises and you start chopping them off. It's kind of like algebra in 3 dimensions, maybe. I don't know. It's probably not a good analogy, but there's a proof. So I'll help you go through the first proof in your booklet, and then I'll let you guys do the work yourself. Now what I've done in the key is I've just told you the final part, right? I said, so if I gave you a question like this, you would see in the key that for this question you would have sine squared theta is equal to sine squared theta, and that would be the last part of it. Now if you're copying, and you just copy that out there, you're going to miss all this other stuff. And that's what I'm looking for, is how did you come to this conclusion, right? So just be aware that, I'm going to be looking for that when I mark your work. So let's do the first one in the booklet. Alright, so here's question 1. Okay, and tangent squared theta plus 1 is equal to tangent squared theta times cotangent theta times cos squared theta. So there's a bunch of ways you can do this solution, and there's no one way that's the right way, and that's kind of why I didn't put all the work in the key, because some people go in many different directions for this. But I'll go in one direction and you can kind of see how this plays out. Maybe you can try it yourself before, pause the video and try it and see what you can come up with. So at first glance, I can notice that tangent squared theta plus 1 is a disguise for something else. And if you look at your sheet, tangent squared theta plus 1 is secant squared theta. So over here, I've got secant squared theta. That's what tangent squared theta plus 1 is. You've hopefully been keeping a little record of those details. And then over there, on the other side, cotangent divided by cosine. Cotangent divided by cosine is cosecant. Right, so this is cosecant squared theta, and then let's not forget that we still have our tangent squared theta still. So this is tangent squared theta, right? So tangent times cosecant. So if you look on your little chart, tangent times cosecant, this guy here is the same as secant, but because they're squareds, it's secant squared theta. So there's a proof. Right? I've got this side over here equaling secant squared theta, and eventually after you remove all the disguises, this side over here is secant squared theta, and so this is both sides equal. Boom. Okay, so ladies and gentlemen, this really kind of concludes the lesson. I just want to give you some pointers or some ideas about how I think about this stuff. For the ones that we do in the booklet, it's the simple version of this kind. Usually it's a squared, usually a squared. So cosine squared equals cosine squared, or whatever, whatever I choose. And one of them, it's 1, it's a value of 1 on both sides. So in the real course, if I had more time, we'd look at a bunch of simplification techniques. So there's things like reciprocals and common denominators, which we saw a tiny bit in the last video lesson. I'm not going to, I don't have time to go into that, this time around. So, and when I set this up with, okay, I just pick, like in this case I picked secant squared theta is equal to secant squared theta, and I wrote backwards. I started the disguise from this piece of information. So this is how I started, and I just worked backwards to disguise them. So they're all simple disguises like that. And your job is just to uncover them, be a little bit of a detective, and use your sleuthing skills to find out which ones are which. Now in the past, we would, there's like 4 lessons to this. So not just 1. And we go into some very fine detail about some of the little tricks, but we don't have time for that. So I rewrote the assignment specifically for this lesson. It's not an assignment from previous years. So I hope I didn't make any mistakes. I did check it, but guys know me, right? Sometimes I make mistakes, so what are you going to do? Okay, so here we have the end of your course, ladies and gentlemen. Congratulations. Like I said, there's no final test. There's no unit test on this. It's if you want to do a rewrite test, you have to make an appointment with me. I sent it out in an email. I think it's on Edmodo as well. You have to make your appointment. If you missed a test, like before spring break or whatever, that counts as 0 until you write it. All right. So make sure that you make the appropriate appointment with me, so that you can get the credit for that test that you wrote. Now, I sent out the days. I think the 18th is the last day. But look, if you need help, or if you need me to come in or whatever, that's fine. If you're doing a rewrite test, you need to get the corrections done on your old test, and so that may mean you need to come back to the school and get your test that you're doing the rewrite for, from your locker or wherever, and do the rewrite test for it. Or you need to get a friend's copy of the test, so get them to take a picture of their test and send it to you, so that you can write it out for yourself, and then do the corrections and come in and do that. Okay, so that's it, folks. It's been a pleasure to teach you. I'm really sorry that the COVID thing happened. What can you do? I know that for many of you, you're going on to great things later on in your life, and you'll be helping to make the world a better place. So I look forward to hearing of your exploits, and please don't be shy to come back and harass us old folky teachers and show us how things are done when you guys get to be in charge. Alright, take care. Miss you guys. Thinking of you lots. Okay, there we go. Cheers. Take care, guys. Love you.